Alright, let's look at the homework 2.4, problem number 9. Alright, a population of bacteria is given by this following function, and what we want to find is the rate of change of the population at t equals 3. Alright, so let's do that. Alright, so since we want the rate of change, we need to find the derivative. So we have a p prime of t is equal to, alright, so 50 is a constant, 500 is a constant multiple, so I'll just leave it outside. Alright, so derivative of 4 is 0, and then derivative of this quotient, we have to use a quotient rule. Alright, so we're gonna square the denominator, so you have 60 plus t squared, alright? And actually, I'm going to leave the 5 outside too, so I'm going to put times 5 here, right? And actually, instead of doing that, can I just multiply 5 and 500? So it's a 2500, right? Right, so since we already took care of this part right here, right? So we take the derivative of the top, which is going to be 1, times the bottom, so we have 60 plus t squared minus top is t times the derivative of the bottom is derivative of 60 is 0. Derivative of t squared would be 2t. So we have a 2t. Right? So we get, let's see, you have a 2500. Right? Then on top, you would have a 60. And you have a t squared minus 2t squared, so minus t squared. Right, then you have a quantity 60 plus t squared, right? So then what we want to do is we just need to plug in t equals 3. So we need to compute that, right? So we're going to have, let's see, 2500, right, over, right, so you have a 60 minus 3 squared, so 60 minus 9, so it's going to be 51 over 60 plus 9, so it's a 69 squared, right? So let's find this value. So I'm going to just pull out a calculator here, and I'm going to put the 2500 times 51 divided by 69 squared, right? Then hit enter. Right, so it's about 26.78. So 26.78. Right, so let's type it in. 26.78. So submit for testing. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.